Midterm was nice, it was okay. I haven't had a chance to check your midterm yet because I'm still really behind on marking this course. I will try to finish homework 3 marking by the end of today, and I'll try to catch up on marking. Let's see. Yeah, I'm almost done with homework 3. The only reason that I'm not done yet is I'm trying to make a marking scheme for the third question, which is identify the surface with the equation phi equals to pi over 7. I wasn't sure what to expect from you because it says identify but didn't specify what exactly you need to write, so I was thinking trying to come up with a marking scheme, but yeah, not sure. Did you guys do any question like that in lecture? Because I might make a reference and mark based on that. So not sure yet. I'll try to come up with a marking scheme and grade that. Anyway, today our plan is to go over Green's theory, curl, and divergence. So those are 16 point. Let me see, 16 point. I think it's 4 and 5. Yeah, 16.4 and 16.5. The material is pretty straightforward. There's nothing complicated. Yeah. So hopefully you guys don't have any problem with this. Okay, let's look at the first one, Green's theory. There's a typo here. Here should be simple. So let's see be a positively oriented, piecewise smooth, simple closed curve in a plane, and let D be the region bounded by C. If P and Q have continuous partial derivatives on an open region that contains D, then we have this. Okay, we have integral along C P dx plus Q dy equals to double integral over D. D is a region, C is a line integral. So this is a line integral, this is a double integral, okay, equals to this, and then notice that those two reverse. So now you have partial derivative of Q with respect to X minus partial derivative of P with respect to Y, dA, which equals to this. So this is just another way to write it. Okay, and note that the notation, the integral with a circle here, is sometimes used to indicate that the line integral is calculated using the positive orientation of the closed curve C. Yeah, that's about it. So I'll give you some time to work on the first example. Example 1, I want you to use green theory, which is this, to evaluate the line integral along the given positively oriented curve, which is this. And my C is the boundary of the region between those two circles. Anyway, give you some time to work on this, and I'll take it up. I'm so sleepy. And I still don't know what to do for 402 yet.
Oh no. I have to work at 11. Night to teach.
It's 10:20 now. 10:17. Okay, I finished writing, so let's take it up. So they want you to compute this line integral according to Green's theory. You can write it as this. Okay, so you're given this, and they want you to write it. You can write it as this. So in this question, this is your P, and this is your Q. So that equals to double integral over d of the partial derivative of x cubed plus e to the y square with respect to x, and minus the partial derivative of 1 minus y cubed with respect to y dA. This will give you 3x squared plus 3y squared dA. And now you can convert it to you can convert this to r and theta. So I forgot to. Oh, never mind. Yeah, so for theta is from 0 to 2 pi, and for r you need to calculate it. So we know that x squared plus y squared is between it equals to 4 and equals to 9. So r squared equals to 4 or 9. So that means my r is in between 2 and 3. So r dr is from 2 and 3. So you take 3 out and then evaluate the integral. That's gonna give you 195 over 2 pi. Any question? Partial d. This. Oh, you don't. This is just another way to write this. Yeah, it's just like a simplified way to write this, but they mean the same thing. Any other question? Okay, if not, let's move on. So Green's theorem also allows you to calculate the area of D, which you can use either of the formula here. Anyone you like, just use one of them. So let's look at example 2. If a circle with radius 1 rolls along the outside of the circle x squared plus y squared equals to 16, a fixed point P on C transits out a curve called the epicycloid with parametric equations x equals to 5 cosine t minus cosine 5t, y equals to 5 sine t minus sine 5t. And I want you to graph this and then find the area it encloses. Okay, so you need to use one of those, anyone you like. Oops. Okay. So, graphing is simple. I'm pretty sure all of you can do it, especially since you have graphing calculator. Um, Now let's find the area. So by this formula, I'm using the first one, this one. We know that area equals to the line integral over cx dy. So x is this, and you need to calculate dy. dy is gonna be this dt. Okay, and now you open the brackets, you'll get this. Simplify that, it's gonna be 25 cosine t squared minus 30 cosine t cosine 5t plus 5 cosine 5t squared dt. And now I split them out because each of those integral is pretty hard to calculate already. So I split them out, factor out the constant, and I got this line. Okay, and for those two, what you can do is you write them as cosine 2t. So use a trig identity. This equals to cosine 2t over 2 plus 1 over 2. And this one is going to be cosine 10t over 2 plus 1 over 2. And the middle one, cosine t cosine 5t equals to 1 over 2 cosine 5t plus cosine 5t minus t dt. So after you split them out, it's much easier to calculate. So this is gonna give you sine 2t over 4 plus t over 2. And the middle part is gonna give you 0. And this part is sine 10t over 20 plus t over 2. And so eventually you'll get 30 pi. Any question? I think it's pretty straightforward. The only difficult part is gonna be uh, the evaluating what's it called? Evaluating the integral. You can use symmetry. Yeah, you can do that. Yeah, you can do that if you want to. You can also use the other two formulas if you want to. As long as you can get the correct answer, you're fine. Although I don't think that's gonna make your life easier because the only thing is like you're changing this, but yeah. Anyway, let's try example 3. So D is a region bounded by the simple closed path C in the xy plane. Use Green's theorem to prove that the coordinates of the centroid D are those two. So I'll remind you what Green's theorem is. So copy paste this and leave it here, just in case you don't remember. Okay, this question should be straightforward, so it should be like 2 or 3 liners. So I'll give you 2 minutes to work on this. let's see. If you leave it in the bowl, it's not gonna eat. But if you feed him, is this a cup from yesterday or this morning? Brownie, are you okay?
Did you feed that?
Yeah, I did. Because it was screaming at me. Brownie, oh yeah, Brownie. I think so. I think 2 days ago he vomited once, and since then he stopped eating. Not really stopped eating, like he doesn't want to eat, but he still ate eventually. And yesterday he had diarrhea. Not sure what happened. Usually when we feed him, he's like really excited and just finish all the food right away. But right now he's not eating. Okay, let's do this one. Should be like 2 lines. Green steering. 1/2a the line integral c along c x squared dy equals 2. So this is basically this with your p equals to 0. So that's going to be 1/2a double integral over d, and then so q is x squared, so take the partial derivative, that's going to be 2x dA. Okay, and then you can factor out 2 and cancel with this 2, so that's going to give you 1/a double integral over dx dA, which is going to be our x bar. Similarly, you can do the same thing for y. It's really similar. So let me change it to y squared. Oops. So, and here is 2y. Oh, it's negative. And here is negative 2y. So negative and negative cancel out, 2 and 2 cancel out. Here is gonna be y, so that equals 2y bar. That's it. There is nothing complicated. Any question? Okay. Now let's move on to curl and divergence. It's basically the same as before, except you're given a new formula. So if F is a vector field and R3 and partial derivatives of PQR all exist, then the curl of F is this, which is just this cross product F. So make sure you remember how to do cross product. If you don't remember, then you memorize this formula, or you don't need to memorize it because it's online anyway. It's open book. So yeah, this is curl, and divergence is just dot product instead of cross product. So that's pretty simple, I think. So this is cross product, divergence is dot product. And we have two theorems. If f is a function of 3 variables and has continuous second order partial derivative, then this equals to 0. And the second one is to if the curl f equals to 0, then f is a conservative vector field. So if they ask you to check if a vector field is conservative, then you check if the curl equals to 0. It's nothing complicated. And I'll give you this example. I want you to find the curl and divergence of the vector field. So you do the cross product and dot product. It's really straightforward. Did it finish?
Yeah, I watched the whole and I just put on the floor and watched the whole and
I think it's because it starts to eat.
I think it's because the bowl was too dirty.
Or brown. Brownie. Oh, so excited. Cute. Okay. I think it's really straightforward. You either use the cross product or you use the formula, which is this. Okay, you can use either of them, it's the same thing to calculate your curl. So that's gonna be x cosine xy minus x cosine zxi minus y cosine xy minus y cosine yzj plus z cosine zx minus z cosine yxk. So compute this. This is gonna give you this. pretty straightforward. The divergence is a dot product, which is the partial derivative of x, y, the partial derivative of sine yz with respect to x. So that's going to be 0 because you don't even have x. And the partial derivative of sine zx with respect to y, that's going to give you 0 as well. And this is going to be 0 as well. So once you add them together, it's going to be 0. So the divergence of f is 0. Any one is wait, one is this equals to 0 in R3 again? Like, when could we use a theory? Which theory are we talking about? This theory? This one or this one? Second. Oh, the second one is saying that if this equals to 0, then you call it conservative vector field. So basically the question will be verify that this vector field is conservative, or check if this is conservative. Yeah. Any other question? So I think you have some questions like that in your textbook. Let's see. Curl and divergence. I think it should be something like that. Verify. Can't find anything at the moment, but I think I saw a question like that somewhere. Yeah, can't find it right now, but yeah, the question is gonna be something like that. Or like when I say, well, this is a conservative vector field, that means this equals to 0. Anyway, let's move on to the next part. So this is another theorem. If F is a vector field, PQR has continuous second order partial derivative. Remember, it's second order? Before it's not, it's partial derivative. Continuous partial derivative. See? Continuous partial derivative. Now it's second order partial derivative, then the divergence of the curl of f equals to 0. Okay? This is second order, the previous one is first order. This is really important, the vector form of Green's theorem. Make sure you know both of them. This is a normal vector, and it's a normal vector. Anyway, let's try example 5. Yep. Oh, no. Give you some time, and I'll go clean Brownie's poop. He has diarrhea again. Brownie, are you okay? Alright. Okay. Did you take class this morning? Total 2 or total 3? Okay, let's take it up. So basically, you need to calculate the divergence of f, which means you need to know your partial derivative with respect to x, y, and z. So to calculate that, we need to know those p, q, and r, right? So to calculate that, we need to first know what our r, not the vector r, but this r equals to x squared plus y squared plus z squared to the power of 1 over 2, which is the square root of this. Okay, so using that, we can calculate those three. And because we have this, we can calculate this in terms of r. So represent your x, y, z in terms of r. So your partial derivative with respect to x is going to give you r squared minus px squared over r to the p plus 2. And similarly, you can do the same thing for y and z, because the only difference of those is just replace this x with y and z. So since you did this, you know that, well, the others just replace this x with y and z. So after we got this, you can calculate the divergence using the dot product. So that's gonna be r squared minus px squared over r to the power of p plus 2 plus r squared minus py squared over r to the p plus 2, and r squared minus pz squared over r to the p plus 2. And after you add them together, you'll get r squared times 3 minus p over r to the p plus 2. Cancel out those 2, then you'll get 3 minus p over r to the p. So this is the divergence of f, and when p equals to 3, okay, the numerator is going to be 0, so the whole thing is going to be 0. That's this question. Any question? So okay. Any question? No? Okay, then I'll see you guys next week.